Hello, hello, hello. If you're watching this, you missed day 2 of our week 12 lecture in Foundation of Technology. Let's go ahead and talk about what you missed. You do need to make sure you complete assignment 21 by Friday. That's tomorrow at midnight, the 20th. And we have one more assignment coming up due next Monday, the 23rd, which is on compound machines. My objectives are that you can name and describe the function of the 6 simple machines, perform calculations using mechanical advantage associated with them, and identify compound machines in the real world and calculate their advantage. Shouldn't be too hard. We started off by talking about what a Newton is, and essentially a Newton is about the force you would experience from roughly a quarter-pound weight resting on your hand. And if you wanted to do 1 joule of work with that weight, you would have to lift it up 1 meter, which is about usually the distance from the floor up to your waist for most people. So that is a kind of good baseline to understand when we're talking about these quantities so that you're not, just lost. What is a Newton? You can watch this video on your own. Let's go ahead and talk about what we did today. So it's been a good chunk of class working through this assignment right here, assignment 21. The first question I'd like to highlight is question number 1, because pulleys are a little bit tricky to calculate mechanical advantage for. One thing you can use to help you understand how they work is posted underneath modules on my MCPS, underneath week 12, and it's called pulley simulation. If you open this up, this is kind of a fun little applet that lets you see how effective your pulley is. If we display the distance we pull here, we can adjust how heavy our load is over here, and we can pull on it by lifting up here to actually initiate the lift. So you'll see that if we show the forces on strands, if we mouse over this one here, that we have 10 newtons is the amount we're pulling, and 10 newtons is the amount that the weight is pushing on our, or putting on our rope there. So there is no mechanical advantage to a single fixed pulley like this. It doesn't do anything. All it does is redirect which direction you need to pull. If you want to have a mechanical advantage, you have to have a movable pulley like this, where this string is affixed to something up there at the top. The pulley can slide up as we pull, and you'll see that the actual force here is 5 newtons on this strand, 5 newtons on this strand, while the force being applied by our weight is 10 newtons. So we're essentially cutting in half the amount of pressure we have to apply to lift this, but as a trade-off, we're unfortunately going to have to pull twice as far, as you see if we go ahead and try pulling it. For every distance we actually move, we have to pull twice as far. Well, there's nothing for free, right? You can also look at a compound pulley. This is the same idea. The actual advantage you'd get out of this would be the same. You would get a 2-to-1 advantage, because remember, this pulley up here just redirects your force, does not actually add to it in any way. We could do something like this, where we have 2 compound pulleys. So if we go ahead and lift this up, maybe this is easier viewed from the front. There's 2 pulleys there working in tandem. So if we were to pull, you'll notice that actually each of the strands is only 2.5 newtons. So this is a 1-to-4 system, and so on and so forth. So how do we use this to solve our question here? Well, if you look at this system, you have to assume the pulley at the top is fixed. Otherwise, this wouldn't float in midair. It would just fall down to the ground, right? So this pulley at the top is fixed. There are some ropes that are going to move when we pull on this rope right here. So one thing you can do in order to figure out the total mechanical advantage is you can look at all the ropes supporting the moving pulleys. So there's 2 ropes supporting this pulley, and then this pulley has 2 ropes supporting it, and this pulley over here is supported by 1 rope. So it's a little bit difficult to visualize that going on, because you have to think about which ropes will move and which ropes won't. So I suggest an easier method. The easier method to consider would be to look at which ropes move and move in different directions when we pull on this strand. We don't count this strand as part of it because if we just had a single fixed pulley, remember, there would be no mechanical advantage. So let's see, if we pull down on this rope over here will move up. Let's keep track of that. That's 1. We go around the bend here, and this rope will move down. That's 2. So if we just had this system, and our weight was over here somehow, this would be 1 to 2. But we have more. We go around this bend, and there's another rope that moves up. That's 3. And we go around one more bend, and this rope would move down. That's 4. This is a 1 to 4 pulley system, where all of these 3 pulleys are going to move when we pull on this strand. And as they move, they're going to distribute the force among them, and you're going to get a mechanical advantage of 4. Hopefully you can use that to solve for number 2. Number 3 involves you calculating the advantage of a wheel and axle. Please remember that the advantage here is the radius of the effort load divided by the radius of the load. You can load different parts of this machine. In this case, the outer rim is being the effort, and the inner part, the axle, is being the load. So you should use the appropriate numbers from your equation. Also note that I'm giving you diameters, and the equation usually, as we looked at it last time, anticipates you using radiuses instead. However, since this is a ratio, it actually doesn't matter if you use a diameter or a radius, you'll get the same answer. So you can divide these by 2 if you like, and then divide those results, one by the other, or you can just divide the diameters as they're given to you. You'll get the same exact answer as your result. Hopefully you can figure out how to do these next couple on your own. If not, please let me know. Send me an email and we can work through them together. The last one to consider is this one, the one with the screw. Now the screw one is a little tricky. For the screw, we are given this classification here. This is a 3/4-10 UNC. What does that mean? The 3/4 regards the top of the screw. The 10 UNC regards the thread count per inch. So if we are going to use a 1-inch diameter screwdriver to screw this screw in, what you would need to do is you would need to consider the 10 as the number you need to calculate your pitch. So how do we calculate the pitch? Well, remember, pitch is really tricky. To calculate the pitch, you need to do 1 divided by the number of threads per inch, or whatever other thing you are using to measure. If it was centimeters or meters, you would use those instead. In this case, we're using inches for everything. So in this particular situation, we would have 1 over, and then how many threads per inch? Well, we have 10 over 1, so we could write that, but really this is the same thing as just 1 over 10. So the pitch of this particular screw is 1 over 10. In order to calculate the mechanical advantage, we have to take the circumference. Remember, the circumference is 2 pi r. 2 times pi times r gives you circumference. In this case, our circumference is 2 times pi times, well, this is a 1-inch diameter screwdriver, so if its diameter is 1 inch, its radius is 1/2, 0.5, which would just give us pi as the result. So the total answer here of the mechanical advantage of this particular screw would be the circumference, pi, divided by 1 over 10, or just 10 times pi. That is your answer. Hopefully that makes sense. This is a little bit more advanced. I wouldn't expect you to be able to figure that out on a quiz or a test, but it's a good exercise to keep in mind. Lastly, I ask you to devise your own simple machine that can provide adequate mechanical advantage to lift a toy car weighing 10 grams, or rather lift a weight weighing 50 grams using the toy car, which weighs 10 grams. Excuse me, sorry about that. So what kind of machine should you use? You have several options here. You could use a lever, you could use a pulley system, you could even maybe use an inclined plane if you're creative. So all sorts of things you can do here. It's up to you to figure out. All right, last thing we talked about today was this idea of compound machines. Compound machines is just a combination of two or more simple machines working in tandem to accomplish the goal. A corkscrew, we already mentioned, is a really interesting one. It has an inclined plane, a wedge, a screw, a lever, and a wheel and axle. Crazy, all going on in that one little object. You can think about a car jack, which is a combination of an inclined plane, a wedge, a screw, and a lever. The lever happens at each of these joints. You have an inclined plane at the top. There's a screw right in here. And it all works beautifully together to jack up your car. For a stapler, each staple is its own little wedge. And the top of your staple, when pressed down on, acts like a lever. So all sorts of good things going on here. Now, how do we actually calculate the mechanical advantage of these things? It's very simple. You take the individual mechanical advantages of the simple machines involved and you multiply them together. The total mechanical advantage is the product of all the simple machines and mechanical advantages individually. So if we look at scissors, scissors are two levers and two wedges. Let's say the mechanical advantage of each wedge is 2. The mechanical advantage of each lever is 4. Well, the two wedges together is 2 times 4, 2 times 2, which gives us 4. And then we have to find out the advantage of all the levers put in there. So 4 times 4 gives us 16, times 2 is 32. So in that particular example, the total mechanical advantage would be 32. Now that's a bit excessive, probably more than you would get out of a pair of scissors, but you get the general idea of how to do the math. Your assignment number 22, which is due next Monday, has you find a machine in the real world that has more than one simple machine in it and is a compound one as a result. You can either take a picture of it or simply find something on the internet that resembles it, list the simple machines, and then if you have the ability to measure the ratios involved, or simply give me a guesstimate that you think is good enough if you have no way to measure, and tell me what the advantage is. Very, very straightforward. If you need to find out the formulas, remember I've given you them up here at the top. You can also simply look them up on Google. That's all I have for you today. Thank you very much, and I'll see you all next time.